Sorry, Hallie, I forgot to record here. I'm going to flash back to this page so you can at least look at it. Here's the work for the other one. You can pause it and look at that. All right, here we are halfway through this problem. We're doing the integral of the top function minus the integral of the bottom function here. We've got, I just like for it to look this way, so I'm going to do negative x squared minus x plus 2. If you want to integrate without doing that, that's okay. And so to integrate, you're going to get x to the third. You have a negative 1/3 out front, minus x squared. You'll get a 1/2 there, and plus 2x. And then we are evaluating that from negative 2 to 1. Here is where it's really important. Make sure you don't just like assume part of that is 0. On this one, it's definitely not, because you're going to have negative 1/3 times 1 to the third power minus 1/2 times 1 squared plus 2 times 1. That's your first section, and then we'll have negative 1/3 times negative 2 cubed minus 1/2 times negative 2 squared plus 2 times negative 2. So we got negative 1/3, negative 1/2 plus 2. Here we're going to get, it's going to be negative 8, so it's going to be 8/3. It's going to be positive 4, so minus half of positive 4 is going to just be 2, and minus 4. I would probably just distribute that negative, just make that negative, that positive, and that positive. So the negative 1/3 and negative 8/3 is going to be negative 9/3, which of course just equals negative 3. We got the 1/2 that won't combine with anything easily, and then we got a 2, and a 4, so that'll give us 8. So we'll get 5 minus 1/2, which will be 4.5. Yeah. If it is FRQ, you can stop right here, but please make sure that you have particularly these parentheses, or you could use a bracket instead. They're really important, because if they're not there, you're wrong. And if the grader is paying close attention, you're going to lose the point if you don't have those parentheses right anyway. However, I'm probably not going to be a grader that is paying close attention if you have the right answer in the end. I did do it right, didn't I? Right. Let's just do this baby on the calculator to make sure. Yeah, 9/2. 4.5. Agree to disagree. All right. Okay. This problem is just asking us to sketch the region. So you're going to see one like this on your. All right. So basically, we need to break it apart into our two functions. Our first function is going to be negative 2x plus 5. So that is just a line. It has a y-intercept at 5. It has a slope of negative 2. I think there are some of these on your assignment, so you may want to get some graph paper before you go and use that. If you don't have any for these problems, it'll make it easier to do the problem. And then I'm going to use red for my x squared minus 3. So you got negative 3 is going to be the intersection, right, your y-intercept here. And then you may remember like the pattern of what this looks like, or you can just plug in numbers. 1 squared minus 3 is negative 2. 2 squared minus 3 is 1. And then that's just going to continue on up like that. Now, this needs one more, well, a couple more things. One more thing for sure. All right? I don't have a region that is closed off here. So what do I need to add? Vertical lines that are endpoints. You could get away with just one of them because you are integrating from 0 to 2. So you could just put the vertical line at 0 because over here at 2, you've got the intersection point of the two graphs anyway. So for this problem, you could just put that vertical line there, and then we are looking at this area right here. So you'll shade that. So your limits on your integral are going to be your vertical lines. Okay. All right, got one more. Okay. Sine and cosine curves intersect at infinitely many places. Find the area of one of the regions bounded by f of x equals sine x and g of x equals cosine x. Okay. So, let's think about it. Let's think about what sine and cosine look like. Let's go, we know maximum of 1, minimum of -1. I'm going to go, let's do pi over 2, pi, 3 pi over 2, pi. Let's do sine in blue. Sine of 0 is 0. You're going to go up, down, minimum, down. So sine looks like this. Cosine starts at a maximum point and then is going to go minimum, or midline, minimum, maximum like this. So you got some options on what to deal with. All of the regions are going to be the same area. So it doesn't matter whether you look at this first one or that second one, or you could, it's going to continue on forever. I'd probably do the first one. You need to know these intersection points. Where's this intersection point at? Think about your unit circle. Where do sine and cosine equal each other? Pi over 4. This is pi over 4. All right. Where do they equal each other again the second time? It's in the first quadrant at pi over 4 right here. It's in the third quadrant over here. What is that? 5 pi over 4. So if we are looking for this region right here, sine would be our top graph, cosine would be our bottom graph. So we would integrate from pi over 4 to 5 pi over 4, and we would be doing sine x minus cosine x. This is pretty simple to integrate because the integral of sine is just negative cosine, and then the integral of cosine is sine. And we are evaluating that from pi over 4 to 5 pi over 4. So that's going to be negative cosine of 5 pi over 4 minus sine of 5 pi over 4 minus negative cosine of pi over 4 minus sine of pi over 4 here. And so this is going to be negative square root of 2 over 2 minus negative square root of 2 over 2. And then over here, we're going to have negative square root of 2 over 2 and square root of 2 over 2. So many negatives. Okay, these become positives. So that's going to be 2 square root of 2 over 2, which we can simplify if we want. And then we're going to have minus negative 2 square root of 2 over 2. These 2's can cancel. So we end up with square root of 2 plus square root of 2, which would be 2 square root of 2. Okay, so assignment is from the textbook. Let me see if it's the same as what I've got on Canvas. Make sure this is the right one. All right, let's see. Yeah, this is the right one. Some of these are going to ask you to sketch, so you may want to grab some graph paper. This is going to be due on Friday, okay? Because tomorrow we are taking our midterm. So if you would rather focus your efforts on either working on test corrections or reviewing for the midterm, you may do that tonight. This will not be due until Friday. Friday, yes.